Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on linear algebra chapter vector space of n-tuples, lecture number 2, in which I will discuss on subspace of an n vector space. Now we define subspace of an n vector space. Let VNF be an n vector space. S be a non-empty subset of VNF, then S is called a subspace of n vector space if number 1 capital X capital Y belong to S, implies that X plus Y belongs to S. Number 2, let K belongs to F, this is field, and X belongs to S, implies that Kx belongs to S. Then S is called a vector subspace of n vector space VNF. Note, every subspace contains zero vector. Clarification: since 0 is an integer, therefore 0 belongs to F, field. Let X is an element of a subspace of an n vector space such that X is not equal to 0. This is 0 vector. If capital X equal to small x1, small x2, small xn, xi belongs to F, I1, 2, n. Let K belongs to F, field, implies that Kx belongs to S subspaces. This is number 2. Let k equal to 0, then 0x belongs to S. Let this is number 1, this is number 2, this is number 3, this is number 4. Implies that 0, x1, x2, dot 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 xn, this is x equal to this, belongs to S. Implies that 0 x1, 0 multiply x1, 0 multiply x2, comma dot 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 0 multiply xn belongs to S. Implies that 0 comma 0 comma dot 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 0 belongs to S. This is 0 vector. 0 belongs to S. 0 equal to 0 vector. Therefore, subspace S contains 0 vector. Therefore, every subspace contains 0 vector. Now we solve a problem. Problem is if capital X is an order triplet. Here components of capital X be x1, x2, x3 is any non-zero vector. Capital X is any non-zero vector of vector space of n-tuple V-N-F. Then so that the set S, capital S, of vectors Kx is a subspace of V-N-F, where K is a variable scalar which can take any value. Now we solve this. Given that capital X equal to order triplet x1, x2, x3 is any non-zero vector of vector space V-N-F, and K is a variable scalar. To show that S is a set containing Kx. K belongs to field. K is variable, is a subspace of V-N-F. Let K1, K2 belong to field F. Implies that K1 plus K2 belongs to F. This is number 1, this is number 2. Again, let C and K belongs to F field. Implies that CK belongs to F field. This is number 3. Since K K1 belongs to field F and X belongs to VNF. Therefore, using 1, we get K1X belongs to S. This is number 4. Similarly, K2 belongs to F, X belongs to VNF, implies that K2X belongs to S. This is number 5. Now, K1X plus K2X equal to K1X means X1, X2, X3 order triplet plus K2 capital X equal to order triplet X1, X2, X3. This is equal to K1 X1, K1 X2, K1 X3 order triplet plus K2 X1, K2 X2, K2 X3 order triplet, and addition will be K1 X1 plus K2 X1 comma K1 X2 plus K2 X2 comma K1 X3 plus K2 X3 order triplet. This is equal to, here we take common X1, K1 plus K2 X1 comma, here take common X2, K1 plus K2 X2 comma, here we take common X3, K1 plus K2 X3 order triplet, and this will be equal to K1 plus K2 multiply order triplet X1, X2, X3. This is equal to K1 plus K2, and this is capital X. This is number 6. From 2, K1 plus K2 belongs to field F and X belongs to Vn. Therefore, using 1, we get K1 plus K2 X belongs to S, implies that K1 plus K2 X, here 6, left side K1 X plus K2 X belongs to S. This is number 7. From 4, 5 and 7 we get K1X, K2X belong to S, implies that K1X plus K2X belongs to S. This is number 8. Let CK belong to field F and let capital X belongs to V and F. Therefore, using 1, we get Kx belongs to S. This is number 9. Now, C Kx equal to C Kx means Kx1, Kx2, Kx3. This equal to Ckx1, Ckx2, Ckx3. This is equal to Ckx1, x2, x3. This is equal to Ck capital X. This is number 10. Since Ck belongs to field F and X belongs to V and F, therefore using 1 we get Ckx belongs to S. This is number 11. From 10 and 11 we get Ckx belongs to S. This is number 12. From 8 and 12 we get that here addition of two members of S belongs to S and multiplication of the vector Kx with scalar C belongs to S denotes that S is a subspace of V and F. Proved. Now we solve the next problem. Next problem is let capital X1, capital X2, capital X3 be any vectors of V3. Then so that the capital S of all vectors of the form Ax1 plus Bx2 plus Cx3 is a subspace of V3 where A, B, C are any scalars. Now we solve this. Given that x1, x2, x3 belong to V3. V3 be the vector space which contains all vectors of 3 tuple. Therefore, capital X1 will be of the form small x1, small x2, small x3. Capital X2 will be of the form small y1, small y2, small y3, and capital X3 will be of the form z1, z2, z3, where xi, yi, zi belong to F field. Since given that S is a set containing all vectors of the form A capital X1 plus B capital X2 plus C capital X3, A, B, C belong to field F, scalars. That is, S is a set containing vectors of the form Ax1 plus Bx2 plus Cx3. A, B, C belong to F, x1, x2, x3 belong to V3. Let this is number 1. Let A1, A2, A3, B1, B2, B3 belong to F, implies that A1 plus B1, A2 plus B2, A3 plus B3 belong to F. Let this is number 2. Therefore, A1 x1 plus A2 x2 plus A3 x3 belongs to S. And B1 x1 plus B2 x2 plus B3 x3 belongs to S. This is number 3. Let capital X equal to A1 x1 plus A2 x2 plus A3 x3 and capital Y equal to B1 x1 plus B2 x2 plus B3 x3. Now capital X plus capital Y equal to, we may write this A1 plus B1 x1 plus A2 plus B2 x2 plus A3 plus B3 x3 using 2 and 1. We get into, we see that A1 plus B1 belongs to F field, A2 plus B2 belongs to F, and A3 plus B3 belongs to F. field, and in 1 this is of the form this x plus y belongs to S. This is number 4. Let K belongs to F implies that KA1, KA2, KA3 belong to F field. Now Kx equal to K, x means A1 x1 plus A2 x2 plus A3 x3. A1 x1 plus A2 x2 plus A3 x3. This equal to KA1 x1 plus KA2 x2 plus KA3 x3. Let this is number 5. Here we see that KA1, KA2, KA3 belongs to field F. Therefore, using 5 and 1, this is of this form, we get Kx equal to Ka1 x1 plus Ka2 x2 plus Ka3 x3 belongs to S. This is number 6. Therefore, from 4 and 6, we get x, y belong to S. K belongs to field F implies that x plus y belongs to S and Kx belongs to S. Therefore, S is a subspace. Proved. From this problem, we got that if x1, x2, x3 belong to V3, means vector space of 3 tuples, then the set formed by all linear combinations of x1, x2, x3 make a subspace S of V3. This type of subspace is known as subspace generated or spanned by vectors x1, x2 and x3. In general, if capital X1, capital X2, capital X R be R vectors generates or spans a vector subspace S, then S is said to be subspace spanned by x1, x2, xr. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button. And if you have not yet subscribed my YouTube channel, then please subscribe my YouTube channel. Thank you.